Hi, this is David from Team Naive BAEs giving our final project report for our NLP semester project. Our task was to create two programs, an Ask program, which takes a Wikipedia article and the number of questions as input, and generates that number of questions about the article, and an Answer program, which takes a Wikipedia article and a list of questions, and attempts to answer those questions fluently and reasonably. Initially, we used NLTK with the Stanford parser for both systems. We tokenized and part-of-speech tagged the input file, and generated some part-of-speech patterns that were easily recognized and easy to turn into questions. For instance, proper noun, verb, noun, such as John ate ham, can be easily turned into WH word, did, proper noun, verb, such as what did John eat? We accounted for the uniqueness of the verb to be, which does not require to do insertion. For example, John is a writer becomes what is John, as well as for verb tense. We also planned to use the nouns to determine which WH word was to be used, but switched approaches before implementing that. The last thing we planned to do was to use WordNet to generate synonyms in our questions to make them more challenging to answer. We abandoned this approach because hard-coded patterns of part-of-speech tags are extremely limiting. For instance, John is a wonderful, fantastic, old dog would be difficult to ask a question about unless we have a pattern that specifically matches determiner, adjective, 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 noun. Clearly, it is better to have a system that can recognize a noun phrase as a whole. We ultimately moved to Spacy because it possessed a better pipeline which handled much of the entire process of going from raw text to question-answer generation. Specifically, tokenizing sentence boundaries, coreference resolution with neural coref, which integrates into the pipeline, part-of-speech tagging, and named entity recognition. Also included is a dependency tree parser and a semantic similarity estimate between tokens and spans of tokens. We then tried a dependency tree-based approach. As a test of this approach, the system looked for a verb as the root of a dependency tree and a proposition that was a child of the root node. It attempted to generate questions based on this verb and its associated preposition. Unfortunately, it did not work well because English prepositions take many meanings based on the verb, and without trying to account for the object of the sentence, the questions generated by the system were ambiguous and very difficult to answer without context. The tree-based approach was abandoned in favor of an NER-based approach. Both our question and answering system go through the same pre-processing steps, which are removing Wikipedia section headers in the input file and using coreference resolution to replace phrases with what they refer to. The Ask system then generates questions based on entities found by the named entity recognizer, scoring them as it goes. It generates a few different question types, and once all questions are generated, the program chooses the top candidates for each type. The answering system looks at sentences in the source and determines which it thinks best matches the question using cosine similarity. We will go into a bit more detail now. First, our Ask program. We experienced that coreference resolution greatly helps in reducing the ambiguity of the text and the number of questions with pronouns in them. Then, the system goes through the text and generates appropriate questions according to the named entity's label. We rank the questions to come up with the best n questions as the output. After generating questions, the Ask program ranks them. As specified in our preliminary report, our system ranks sentences from the source article according to a self-defined measure of the well-definedness of context. Questions are first categorized by the kind of named entity that they ask about. In our implementation, each named entity starts off with a base score, and if the entity is mentioned frequently in the text, then we increase the score of that question. We do this in an attempt to generate questions about subjects that the article covers most. Now for our Answer program. The input is a Wikipedia article and a list of questions. We begin by parsing the article and removing the headers. Then the answer system goes through every sentence of the article and uses semantic similarity based on the English word vector model provided to Spacy to guess which answer is most relevant to that question. It goes through the question and looks for certain words in the question. If the question contains a certain set of WH words, then the program will increase the score for sentences that appear to have something corresponding to those words. If the named entities in the question match the named entities in the sentence, then the sentence gets an even higher score. At the end, if the score of every candidate is below some minimum threshold, then this means that no candidate has a high enough semantic similarity. If this is the case, then the system returns an answer of, "I don't know." Pursuant to our plans in our progress report, the current system is capable of asking more varied questions. Since our progress report, we moved from NLTK to spaCy for its improved functionality to help build the system. spaCy's many freely available NLP tools aided the overall system in handling multiple levels of pre-processing of the input articles, such as sentence boundary detection, tokenization, parsing, named entity recognition, and co-reference resolution. It allowed us to move away from hard-coded, handwritten transformation rules, which were not easily extensible. And that is how we implemented our question and answer system. Thank you for listening.